A neuron, like any cell, has a cell membrane and a cell body. Now, the cell membrane, you can think of it as being like a plastic bag that holds the contents of the cell together. But this plastic bag is made of a thin layer of fat. And in that plastic bag are stuck lumps of protein. And some of these lumps of protein have holes. They're kind of like donuts. Now, these lumps of protein are called receptors. And they are the way that the cell communicates. They're the way the cell learns, they're the way the cell changes, they're the way the cell interacts with its environment. So if you imagine the cell membrane as this layer of fat, and through the fat is stuck this complicated structure which can change its shape in response to electrical activity. You get various types of receptors. One is known as the ion channels. So, for example, there are sodium ion channels in neurons, and they allow sodium ions from the outside of the cell to come into the cell. Once inside, they can then be pumped out by various specialized mechanisms inside the cell, but the point is that it's the ion channels that allow the cell to regulate which ions are inside and which ions are outside. Now, by doing that, the cell can control its electrical balance, the difference, if you like, between the charge outside and inside. And that difference is usually about minus 70 millivolts, and that's called the resting potential. It's the electrical potential across the membrane, and it's negative. That resting potential is what changes when a neuron fires, when it's activated, when it produces an action potential. And as the name suggests, an action potential is a very rapid, sudden surge in the electrical potential across the membrane. So it becomes rapidly much more positive, and the reason it becomes more positive is because sodium ion channels have opened, and sodium ions, which are positively charged, are flooding into the cell, so the negative charge, the resting potential, becomes much more positive, and you see that on a graph as a very sharp electrical spike. After the sodium ion channels open, you can then get other ion channels opening. These are potassium ion channels. Now, normally the cell has much more potassium inside than out. So when you open the potassium ion channels, because potassium is positive, it flows out of the cell, because positive ions are, in anthropomorphic terms, always trying to get away from positive ions and towards negative ones. So the potassium flows out of the cell, and that rebalances the electrical potential across the membrane, because the positive sodium has come in and made it more positive, and then the positively potassium flows out, and that rebalances the membrane. There's always a little overshoot called a hyperpolarization, but basically what you get is a graph that looks something like this, going right up and then down and overshooting a little and coming back to where it was. And that's the action potential. And a neuron can fire off those about once every 3 milliseconds, thousandths of a second. So it's a very fast mechanism.